a book on a table, you observe that it stops after moving some distance. Repeat this activity pushing the book from the opposite direction. Does the book stop this time too? Can you think of an explanation? Can we say that a force must be acting on the book opposing its motion? This force is called the force of friction. So friction opposes relative motion between the surface of the book and the table. So what situation they are giving you here is, children, in this activity? You can try almost all the activities given here, children. They are very interesting and very simple, so that you can perform at home with the things available. So activity 8.1 says is, if you just push a book on the floor, what will happen? The book will move. Will it keep on moving? No, it will come to rest after moving certain distance. Why? Because the frictional force is opposing the motion of the book. In the chapter Force and Pressure, children, we studied an example. What was it? A boy trying to push a car which is stationary, means which is at rest. The boy was not at all able to push the car, though he is applying all force what is available in his body, is spending whole energy and trying to push the car, but the car is not at all moving. Why do you think the car is not moving? Yes, of course, one thought what comes to your mind is the concept of force, that is the force applied by that person is not sufficient in order to move the car. Yes, you're right, of course. But now if you relate that to this situation, children, there is frictional force present between the road and the tire of the car. So the due to the frictional force, the person who is pushing the car is not able to move the car. So if 2 or 3 persons, when they try to push the car, the same car, yes, it moved a distance, a certain distance. What happened now means the amount of force is increased. Of course, the answer is right. The amount of force is increased, but the amount of force applied by these 2 to 3 persons on the car has overcome the frictional force which is present between the tire and the road. That is the reason the car started to move. Even you can relate it to some situation. A big wooden block is kept there. If you are trying to push, the block doesn't move. Why? Because the force you are applying is not sufficient is one side, but on the other side, children, the frictional force is present between the floor and the wooden block, which is opposing the motion of the wooden block. What you need to do is, you should apply more force, that is the force which you are applying, that is the external force applied by you, should be more than the frictional force present between the surface and the wooden block. Then only the wooden block will start to move. So everywhere we see this frictional force, children. The same thing in activity 8.1 also, when you try to push the book, it will move to certain distance and come to rest. Why? Because there is the frictional force is present between the surface of the book and of course the surface of the table. Can you think of an explanation? This is the explanation. Can we say that the force must be acting on the book opposing its motion? This force is called the frictional force. Yes. So even though I am applying, what they mean here is, even though I am applying the force to push the book from that side, the book is stopping at certain point. Why? Because some other force is opposing the motion of the book. Which force is that? Of course, it is the frictional force, children. It is the frictional force. So you saw that if you apply the force along the left, friction acts along the right. If you apply the force along the right, then the friction acts along the left direction. In both the cases, the force opposes the motion of the book. The force of friction always opposes the applied force. Yes, no, this is the very best situation. Activity 8.119. I am pushing the book towards my right side now. This is my right side. I am pushing the book towards right. Means the book will come to rest here. Will it jump, come here and come to rest on my left side? No. So when I push the book here by applying the force on the, imagine there is a table and I am trying to push the book. After moving certain distance, the book came to rest. Why? Just now we studied that the frictional force is opposing the motion of the book. Motion of the book. Now I am applying the force towards my right, but the frictional force is stopping the book. Means in which direction is it acting? It is acting on the book. Means it is acting towards the left direction. Similarly, if I push the book towards my left, from towards the right direction, the frictional force is acting, which is opposing the motion of the book. So in whichever direction you are applying the force, in the opposite direction the frictional force is acting and opposing the motion of the objects, children. In whichever direction you are, suppose you are applying towards the right, the frictional force is acting towards the left. Left ಗೆ apply ಮಾಡಿದ್ರೆ right ಗೆ apply ಆಗುತ್ತೆ ಹಂಗೆ. So that is what the statement means. You please underline that while reading the textbook. If you apply the force along the left, which force, external force what you are applying is they are telling about. Frictional force acts along the right. If you apply the force along the right, then the frictional force is acting along the left. In both the cases, the forces are acting and opposing the motion of the object. That is in general. Here in book they have given. The force of friction always opposes the applied force. Yes, true. In the above activity, the force of friction acts between the surface of the book and the surface of the table. Is the friction the same for all the surface? Does it depend on the smoothness of the surface? Let us find out. We considered few situations. Now here itself we got the answer to this question. See, isn't it, children? It is difficult to walk on a slippery road, means friction is very less, so that is the reason we slip and fall easily. But if you are walking on a tar road, you doesn't slip and fall easily though the road is wet. Why? Because it is rough surface. So rough surface means friction should be more, smooth surface means friction is less, so we fall easily. This is the answer, children. So let us find out what they have given. Factors affecting the friction is the next concept. You have one more interesting activity. Tie a string around the brick. Pull the brick by spring balance. You need to apply some force. Note down the reading on the spring balance when the brick just begins to move. It gives you a measure of force of friction between the surface of the brick and the floor. Now wrap a piece of polythene around the brick and repeat the activity. Do you observe any difference in the readings of the spring balance in the above two cases? What might be the reason for this difference? Repeat this activity by wrapping a piece of jute bag around the brick. What do you observe is the question. So, what this activity says is, they are talking about the spring balance here. In different measuring instruments, you might have studied about this spring balance, children. So, spring balance, the name itself tells us it has a spring motion. So, this picture of the spring balance has been given in your textbook, and what it is also they have explained. So, let us understand what is spring balance and then go back to the activity. The spring balance is there in the physics lab, children. I can show it to you. I will show you how it works, and that video also I will send it to you. So spring balance is a device used for measuring the force acting on an object. So what is the spring balance? It is a device which is used to measure the force acting on any object. It consists of a coiled spring. I said no, coiled spring means like this. It consists of a coiled spring which gets stretched when force is applied on it. So the spring balance, you all have habit of playing with the spring, or else just remove out the back cover of any pen, the tuck pen, what you say, children. It consists of spring inside it. Yes, no, if you apply the force, what will happen from both the side? I will draw and show it to you. When applied the force, it get compressed like this. The spring, the coil will be very close to each other. But when you expand or pull it from either side, the coil expands, it moves away. In the spring balance also, it consists of a coiled spring. Whenever the weight is hanged to it, what happens when an object is hanged means due to that weight, the spring gets stretched. The spring will get stretched due to weight of the object. Stretching of the spring is measured by a pointer moving on the graduated scale. You have seen the scale. No, graduated scale means a scale which has a marking on it. I will clean this part of the board so that I can show it to you, children. The spring balance, it looks something like this. It will be rectangle in shape. The surface of body will be rectangle in shape, and you have the graduations or the marking like this, 5, 10, 15, 20 anta. And you have the spring or the spring or the other spring. You have the spring inside and the hook or the support to which the object should be tied. Here they are telling with the help of thread they have tied a brick to the spring balance hook. So when without any object tied to the hook, children, the spring will be compressed. It will be compressed like this. The coil will be closer to each other. The moment the brick is hanged, what will happen is the spring gets expanded, the spring gets stretched. The spring will get stretched. Why? Due to the weight of the brick, children. So as the spring gets stretched, you have a pointer like here, children, that will go down along with the spring. So it will show the readings here, maybe 5, 10, 15 like that. Wherever it stops, through this pointer, the reading is noted down. That is how it works. The reading of the scale gives the magnitude of the force. So in this activity, they have hanged the big brick to the spring balance. So you hold the handle of the spring balance and try to lift the brick along with the spring balance, they are telling you. When you do so, it gives you the measure of force of friction between the surface of the brick and the floor. When you are lifting the spring balance, which is tied to a brick, children, so the spring balance pointer shows some reading, which gives us that reading gives the force acting between the brick and the surface. That is what they are telling now. And also they are telling you to feel how much force or pressure you are applying in order to lift the spring balance with the brick. In the next situation, they are telling to wrap this brick with the polythene cover. Cover the brick with the polythene cover and now again try to lift the spring balance. And in the third case, they are telling us to cover this brick with the gunny bag. You all know the gunny bag. Gunny bag, and again try to lift the brick with the spring balance. What will happen is the question. In which case you felt difficulty in lifting is the question. Here, of course, the polythene cover means it has a smooth texture. It has smooth surface. So it will be easy for us to lift the brick, overcoming the frictional force present between the surface and the polythene cover which is covering the brick. But in case of a gunny bag, you know gunny bag has very rough surface. It is very rough to touch also. So when this brick is covered with the gunny bag, since the surface of the gunny bag is too rough, children, when you try to pull the brick with the help of spring balance, you may have to apply more force in order to lift the brick when it is covered with the gunny bag compared to that covered with the polythene cover. The reason is only because the surface area of the gunny bag is rough, whereas the surface area of the polythene cover is smooth. That is the reason. So repeat this activity by wrapping a piece of jute bag around jute bag, gunny bag around the brick. What do you observe? So this is what we observe, children. Next you have activity 8.3. Make an inclined plane on a smooth floor or on a table. You may use a wooden board supported by bricks or hooks. Put a mark with a pen on any point A on the inclined plane. Now let a pencil cell move down from this point. How far does it move on the table before coming to rest? Note down the distance. Now spread a piece of cloth over the table. Make sure that there are no wrinkles in the cloth. Try the activity again. Repeat the activity by spreading a thin layer of sand over the table. Maintain the same slope throughout the activity. So what they are telling us to create an inclined plane. You are played with a slide. That is an inclined plane. So with the help of some support, maybe books or bricks or whatever you want to keep here for the support, and create an inclined plane. You can use the wooden floor. If you want, you can just use the wooden scale also, but let it be little wider, children. And this is the inclined plane. Now just drop a pencil shell. You use for the torch, for the TV remotes and all. Now that pencil shell, imagine this chalk itself as the pencil shell. Just leave it to roll like this on the inclined plane. So when it rolls and comes down, children, wherever it comes and stops on the table, note down the distance from this inclined plane to the where this cell stopped moving. Note down the distance. Next what you do is, on the table surface. Now spread the cloth, smooth cloth you spread. Again allow the pencil torch to roll on the inclined plane and fall on the cloth now, piece of cloth. Again note down the distance. Next they are telling to replace the cloth by some sand, create the surface of sand there, drop some sand and put some sand and again make the same pencil torch shell to roll. So again it will come, of course it will, in all the three cases it will come to the state of rest after rolling down the inclined plane. In which case the distance travelled by the pencil shell was more and in which case it was minimum. That is what they are questioning us. So what do you think can happen, children? Of course when it was just dropped on the surface of the table, it moved to some distance. But when we drop the smooth cloth, the surface area is so smooth as we said, hence it may move little further when compared to just dropped on the table surface. But when we put the sand, children, sand is very rough. It is very rough texture. So the least distance travelled by this pencil shell is on the sand, whereas the maximum distance covered may be on the smooth cloth of the on the table which was spreaded. So in which case it was maximum, which case it was minimum. So cloth has the smooth texture, so friction is less, means it will travel longer distance. But sand means it cannot roll on the surface of the sand, hence it will come to rest very fast and hence the distance covered by that cell is less in case of the sand, on the sand surface, children. That is what we observe. You can try this activity at home, it is very simple. In which case the distance covered is minimum. Why is the distance covered by the pencil shell different every time? Try to reason why, discuss the result. Why it is different every time means it depends on the texture of the surface, whether it is rough surface or smooth surface or all that matters, children. Does the distance covered by the, distance covered depend on the nature of the surface on which cell moves? Of course it depends on the nature of the surface, and the smooth area, rough area, all that matters, children. Could the smoothness of the surface of the cell affect the distance travelled by it? Yes, it will affect. If the cell surface is smooth, then it can easily roll down. But if you make few cuts on those surface and leave, children, again the surface will become rough and again the distance moved will be less. That is what they are telling. See, they have given here. I shall try the activity by wrapping a piece of sandpaper around the cell. Sandpaper means, of course, it is rough surface. No, so when you roll the cell with the sandpaper and allow it, of course it will move very less distance, minimum distance. Why? Because the surface of sandpaper is very rough.